So for this afternoon session, we're going to be focusing on AI's transformative impact on energy and utilities. So AI and modern technology are fundamentally reshaping the energy and utilities sector. Our expert panel will delve into real-world examples showing how intelligent solutions are enhancing grid management, energy trading, and customer engagement. For this session, we will discover the strategic advantages these innovations deliver and the essential technology foundations needed to implement them rapidly and effectively across large-scale operations. For this session, we have our moderator, Ashwin Ramasamy. Ashwin is the co-founder and CEO of Moative, which is a quant-grade AI company that consults and incubates ventures in clean energy, pharma, healthcare, and government. Ashwin has previously built and sold Pipe Candy, an AI company in the e-commerce intelligence space, and Contract IQ, which is a marketplace for IT services. Thanks for joining us, Ashwin. Our two panelists for this session are Shrikanth and Anand. A little bit about Shrikanth and Anand. So Shrikanth is the co-founder of Moative along with Ashwin. I just told you that they focus on incubating companies and ventures in the clean energy, pharma, and healthcare space. In addition to that, he was also Ashwin's co-founder at Pipe Candy, and he has over 2 decades of experience in data science and AI across industry domains and functions. Thank you for joining us, Shrikanth. Our next panelist is Anand. Anand is the founder and CTO of Mad Street Den, where he leads the development of vue.ai, which is a generalizable AI engine and orchestration platform used across retail, healthcare, insurance, and more. His work spans AI systems, neuromorphic engineering, and neuroscience, with experience collaborating with IBM and Stanford. Anand has spent his career building adaptive systems that drive intelligent automation at scale. So without further ado, I'm going to invite Ashwin, Shrikanth, and Anand to join us on stage and take us through this really interesting conversation.
Thank you. How many of you are actually from the energy domain or know anything from energy domain? Interests? Okay, so we'll keep it like light on energy and like spend more time actually talking about orchestrating AI systems at a scale and sophistication that an industry like energy would demand. So think of the energy case that we're going to talk about as a background story to talk about what it takes to do enterprise AI orchestration. So we just flip the narrative a little bit so that it's all relevant for all of you guys, right? Or you can take this as like a boring session. You're all sleep deprived anyway. You can use this opportunity to sleep a little bit, whichever works. AI and energy is like the perfect epitome of an unstoppable force meeting an immovable object, right? So algorithms are like, there is no dearth of like ability to build algorithms. Compute is available if you throw money at it, and there are big companies which are like building like the compute infrastructure that is needed. What is in short supply is actually energy. So when Google or OpenAI want to build data centers, the first thing they encounter is a small like county somewhere in like Western Texas who still works in like Excel sheets and like don't do anything about like grid optimization because like they have 4 people like doing customer support. So it literally is a case where like a major force like AI is coming in, but bottlenecked by what the energy industry can actually do or cannot do, right? So that is the backdrop of our story. So a little bit about, I'll move the slide so I can see, a little bit about the energy industry, right? There is generation, there is trading or wholesale of energy as a commodity. Then there is transmitting that energy, and then there is retailing that energy. This is kind of what the industry is. Generation and retail, which is the 2 ends of the spectrum, is where most of the revenue is, 35-40% each. Trading and wholesale is a small part, like 5-10%, and transmission is 15-20%. But it's all a very weird industry if you're coming from for-profit, like, financial services or e-commerce and healthcare, not healthcare so much, bio and so on, because it's a very regulated industry irrespective of which part of the world you go to. The profit margins are capped. If you are a utility company, you can only have 15% profit margin. If you are a trading company, the profit margin is unlimited, but uh, whatever opportunity is available for you to make money as a trader, somebody else is going to come in and quickly close that gap because it's a very, very competitive space within this segment. Transmission is the biggest reason why AI will be rate limited. You can potentially produce a lot of energy. You can probably go with nuclear fission, but like the pipe which will take that energy to a central grid is all 50, 100 years old. Trillions of dollars have to be spent on rewiring or adding new transmission line. America does not have the money to do it. So you need to squeeze efficiency out of these transmission lines. So this is a rate limiting factor for AI. Right? All the innovation that is going into AI for transmission is going into finding out like which lines are faulty, like where like there is like likelihood of a transmission failure and fixing it. Maintenance is where the AI opportunity is. Trading, on the other hand, is where like exciting amount of opportunity is there for AI, because the world is changing a lot, not metaphorically but really speaking. Like there are like places which are getting flooded during seasons which you don't expect, like any rain, right? So extreme weather conditions are no longer abnormal. Extreme weather is the norm, right? So your weather prediction would say today there will be a snowstorm and there will be 5 inches of snow, but like it happens to be 15 inches of snow. Nobody anticipated it. So how would how would power demand change? So these are all areas where like there is a lot of AI impact, and generative AI's impact is like even more interesting here because this is an opportunity that nobody is pursuing. For example, how does Trump's statement affect power demand today? How does how does an announcement about tax credits in the energy market drive demand next 1 month? So behavior modeling, market modeling, these are all opportunities available. These are all opportunities that will be taken. So this is where AI is playing a role. The role of AI in retail is fairly understandable. Retail is retail, whether you're selling e-commerce or like energy, right? There are customers, they buy products in prepaid or postpaid. Like you can upsell customers, you can cross-sell customers. They're going to call and complain about power not being available or outage. You can put bots to manage it. You can replace customer support with bots. All of that is familiar territory for most of you if you are in the consumer space or the consumer tech space. It's all the same here, except that the complexity comes in ways which are only relevant for the utility industry. If you are consuming X kilowatt power, can I tell you that, hey, switch off your air conditioner from morning 5 a.m. to 7 a.m. because that's what is consuming a lot of power. And if you stop that, I'm going to give you $50 reward. That's what the industry wants to do. And that's a holy grail. It's called demand response. That's the holy grail in this industry. Several companies, venture funded companies, are trying to solve this, right? Which is fingerprinting the consumption of power at a disaggregated level by EV charging or your bread toaster and oven and so on. So this is where the opportunities are. The profit margin is the highest in generation and like retail, but it's very difficult to get into this industry for generation, primarily because I'll give you an example, right? The largest generator in the US, our second largest generator in the US, has like $40 billion deployed into generation. It's not a startup scheme, it's a capital intensive business. But services, AI services for that industry is something that you can all look at. So this is kind of the landscape of like how power and utilities work. And I've specifically focused only on the clean tech side of things. Right? We'll talk about one use case, and we'll take this use case as a way to talk about what it means to build and deploy several models at scale very quickly in the wake of fast moving data. When I say fast moving data, market signals change every 15 minutes in this market. you need to react to it. And the ability to react, or the efficiency with which you react to the market, determines whether you're going to make money or lose money, not just for that day, but for that entire year. Right? There is so much of hundreds of millions of dollars at stake if you, depending on whether you react well or you don't react well. Right? So that is energy risk management. The risk of like buying energy at the wrong price or the right price is what we are talking about. Right? Shrikanth, do you want to talk about the use case a little bit?
Yeah, sure. Yeah. So, Ashwin spoke about the entire value chain, right? So we are talking here in this use case, consider a renewable energy utility company, right? So they purchase energy from renewable energy generators, solar, wind, and so on, and they supply it to their consumers, which is could be consumers, commercial players, households, so on, right? So on both sides, on the supply chain side, where you have generators who are providing power to this utility company, that's renewable, which means affected by weather patterns. So think of, say, sudden storms happening, or a cloudy day, solar not generating properly. So a cloudy day with no wind, so solar and wind both going down. So there's a lot of high volatility on the supply side, where you've predicted whether the weather predictions may go wrong, or weather might change, and the power that you've purchased may no longer be available, or you need to make up for it somehow, right? On the same side, on the other hand, on the demand side, right? So you have houses, residential households, which have specific energy consumption patterns, right? So most houses say morning there's high consumptions, daytime there's kind of a lull, and then again evenings it goes up. But daytime is when commercial power picks up. So you have different customers, different having different consumption patterns throughout the day. This also repeats over weekdays and weekends. So right, so weekends residential might have higher consumption, commercial will have lower consumption, right? I mean, assuming, right? Similarly, again, over seasons, over holidays, and so on. There's a lot of patterns around how different people are, even within commercial. Is it like, say, offices or restaurants or hotels? Or is it, say, something like a data center out in, say, West Texas, or maybe a crypto mining company which is running, say, mining for bitcoins somewhere, right? So all of them have different weather consumption patterns, which depend both on weather as well as the pricing conditions, right? And so you have variability in demand as well as supply based on this weather, and this is not really easily predictable, especially if you start going granular, right? Also, for a utility company, you need to be really aware of the consumption patterns of your different kinds of customers and build a portfolio that matches this kind of variability in patterns, right? So you need to have a good mix of, say, residential customers and commercial customers, so that when residential demand goes down, commercial demand goes up, but your overall consumption pattern as a company and as a portfolio remains kind of steady, right? So these are,
And there are penalties if you don't serve
yeah,
power.
yeah,
Right?
and yeah, like, yes, and so energy and utility is a utility, right? I mean, it's a public service, and if you don't service, if you don't provide power, then there are penalties around it, regulations around it, right? Especially when, say, in summer or winter, when there is high heat or really severe cold days, when demand spikes, and that's typically when generation also falls. So utility companies kind of scramble to purchase power from wherever it's available, and so predicting these days. So if you look at a 365-day period, right, in almost 310, 320 days, when nothing out of the ordinary happens, when energy, so weather forecasts are fairly standard, typically, I mean, you don't if it says it'll rain, and so on. Energy focus, power focus on most days, 90% of the days are all, I mean, taken care of, is normal. It's those 20 days in a year, and even within those 20 days, maybe what 3-4 hours on this each day, when power spike, when demand spikes and prices spike, that's when you need to, the utilities or others have the ability to make or lose a lot of money, and it's precisely forecasting that, not really accurately, but at least forecasting it ahead of the market, right?
Yeah, when
Could
we
be-
say when we say money, a trading firm can be in business or go out of business just because they made the right or wrong call within for those 3 hours in the year. So 150, $200 million of profit, which is a fantastic year, or like you are in the hole for like $200 million, right? So it's a very conservative industry. They would have built a model like some 15, 20 years, 30 years back. They will work with the model. They know they are not going to lose money. They will leave a lot of money on the table because they don't want to be losing money, right? So it's very difficult to go and tell that industry that like there are new AI models, there are new ways of doing things. You will make a lot of money. The first question is like, am I going to lose money, right? That's the industry.
yeah. Okay. So basically, risk here means you have both demand and supply side risk, which is then with a combined, you can come up with market and price risk. Couple of things which we've left out here deliberately. I mean, like Ashwin mentioned earlier, right? Grid, the energy grid, the distribution mechanism, the power lines are all ancient, and there's a even if you have power, you may not be able to send it across from one grid to the another grid. Like think of, for example, India, right? India, say, so Tamil Nadu may have excess power, but can they send it to Karnataka or Maharashtra? Same kind of situation happens there, because there are bottlenecks in the grid. How much power can you send from one grid system to the other, and so on? And these are also factors in how you can manage these risks, right? So traditionally, again, from forecasting demand as well as forecasting, generation, there have been standard, say, forecasting models which have been used.
Shrikanth, just sorry, 1 second. So we are now switching from, so we've set the context now on what this industry is, what kind of risks they face, and what kind of money is on the table, and how they have been like working in the past. So now between the three of us, like what we have been doing over the last 6 months or so is to work with energy trading firms which have a startup mindset, backed by big balance sheets, wanting to shake up this industry. And what does shaking this industry mean? What kind of technologies that we are recruiting to, like, orchestrate like AI better for this industry is what we are going to talk about. While we are going to talk about the energy use case here, the specific use case, the risk management use case, the principles that we are going to talk about here apply to other industries also, right? So yeah, so I actually will start with them on what orchestration means. We threw this word a couple of times, but let's start with what orchestration is.
Sure, thanks. I'm just going to pick on a couple of words they use, a couple of sentences, and then frame how I'm going to describe this. Ashwin mentioned that you have a lot of changing conditions in the industry, whether they are weather patterns, the variabilities that come from things like that. Shrikanth talked about, whichever one of you talked about, companies running on extremely old models because they don't want to run the risk of losing money. How do you deal with it? You need to answer questions within a very small number of hours on a very small number of days, which means the bulk of the data flowing into the system. And there is a ton of data. There is IoT data from the production systems. There is information coming from the trading side. There is information coming from weather signals from multiple sources. All of these signals are coming in. There is no shortage of data, but you have to act on the right data in a tiny sliver of time. So what do you build? So let's work backwards. You could build one model to rule them all. I mean, that's what everybody's trying to do, right? You have these fantastic models that are coming out, which have trillions of parameters that handle every input variation and give you an answer. Not going to work. The models that have been running, the 15-year-old models, cater to the mean. They don't take a risk. They're not that reactive to the changes that happen. If you, as a human operation, want to handle the system, you will hire specialists who are very good at understanding these signals when they happen, and their job will be to be right for that 2 days of the year and prepare for it. And you will have all kinds of people working for the other 300 days where their job is to simply run the system. You compartmentalize the work because different people have different skills. So if you're trying to solve this problem, you have to account for the millions, billions, trillions of signals that are coming in real time from the field. You need to have different specialists who are good at understanding those signals and transforming it in a form or a smaller set of signals that somebody can act on. You can't feed all that raw information into a system and expect it to behave. So you have to take that data coming from all these sources, pull it in, so orchestrate the movement of data. You have to transform it using a whole bunch of AI models so that it becomes a feature that can then feed into another set of specialist models. So it's models acting on the output of models, acting on the output of other models, acting on the raw data. So moving all this information, all coming at different time frames, bubbling it up to the right people, sending those signals out to the people who can act on it, whether it's at a power plant or at a trading desk, and having them act on it. And of course, then you have to deal with the system there where your action is going to cause a reaction, which is going to change the entire model itself. Because your action is going to now change the input signal, and you have to switch the model to behave in a different paradigm. So moving all of this is orchestration. Moving the data, transforming it, sending it to the right place, reacting to the actions that come out of humans interacting with their data or automated systems requires orchestration.
Yeah. So I'll just touch upon the point that you talked about. Like your action will lead to a reaction, and then you need to model for it. So let's say there are 10 traders in the market. If you have 5% market share, your action may not trigger a lot of change in the market. If you are the big whale which is trading like hundreds of millions of dollars every day, and you're using something like this, your action in the market will actually move the market. So you need to react to that immediately, right? They will react immediately because they are the ones triggering the market. The rest of the ones have to react within like 10 minutes or 15 minutes, right? That's where so what happens today is, let's leave the market actions. Weather changes. The trader calls the weather model provider, says, hey, weather has changed beyond what was anticipated. Can you rerun the models and give me some output? They'll take 4 hours, 5 hours. By then, the trading opportunity is gone. That's how the industry works. So I actually want to take the example of load forecasting. Load here means demand, right? Demand forecasting, load forecasting. Load forecasting has been done since the power industry has been there and they are trading on it. What is different now?
Yeah. So Ashwin said, right? I mean, load forecasting, forecasting demand for power, whether it's from households or commercial industries, has been like a something that people have been building for a long time, right? But also, I think Anand alluded to, a lot of the models, traditional machine learning statistical models, are trying to cater to the mean, right? So I mean, to take a simplistic example, right? So one of the things, measures of accuracy for a forecasting model would be something called average error, right? Or I mean, MAPE or whatever, right? So there you might have an average accuracy across your forecasting period, say 45-day, 30-day, 90-day period of say less than 5% error. But on that one day within that 45 days, when say prices go up, there your error might be 40%, and you lost money, right? So overall, the model was really good. Statistical model was really good. You're getting 2%, 3% average accuracy, except for one day. But that one day makes or breaks your business, right? So how do you build newer algorithms that will identify these sudden shifts right? And again, like I said, we need to identify it not really accurately to say 2%, 3% accuracy, but identify the trend well enough and in advance that you can hedge for it, or you can be slightly ahead of the market and account for it, right? This will help not only from a trading perspective, but also the fact that you have purchased power to actually supply your customers, right? And that's where some of the newer models that we're using are coming in. We are right now, and that's where I think, like Anand also mentioned, right? So on most normal days, you have a general model which is a standard model, but can you keep identifying your input signals and say, oh, tomorrow is likely to be an unusual day. So for this unusual day, bringing in a specialist model and run that model specifically for these 3-4 days, right, in parallel.
Yeah, you go ahead and then I'll follow up.
Yeah, no, just pointing out what he said can blow up your entire AI and cloud budget if you don't run it the right way.
Yes.
If I have the specialist model running for 365 days, but it's needed for 2 days, you'll blow through your budget as well.
Exactly.
So you need the recruitment and the federation of different models on different days. And so you have to have models that are detecting the change that will then recruit other models, bring them in to calculate what you need just in time for his trading guy to make a change in that 4 hours.
Yeah. So this is a good jump off point to talk about orchestration, not just in the context of energy, but generally from a data scientist or data engineer's throughput point of view. How does orchestration change their world? Can you talk about that?
Sure. So traditionally, the process of building models has been pretty difficult. You need data scientists, data engineers. They prepare. One group prepares your data, another group solves the problem or builds a model, and then there's a disconnect for who is actually going to deploy it, monitor it, and make it work in the real world. And the jargon words that are out there are very real. You need MLOps, right? The MLOps is the field that keeps track of, you have deployed something. Is it effective? Does it need a change? When do I pull back the data scientist to build the next model? Or when do I build an automated system that can retrain the models and push it into production? You need this to be a dynamic system that's acting on signals at a particular cadence. You'll figure that out as you operate such a system. Now, this traditionally was the job of so many people with so many different skill sets. The data engineer had the messy job of actually grinding through all of those input signals and making sure it's easily available. And then the data scientist will walk in like a diva and say, yes, okay, you've given me clean data. I'll build a model for you. It'll be the best model ever. And then the data scientist is like, oh, your model didn't perform. Why? That's not my problem. Somebody else deployed it. They deployed it wrong. Nobody monitored whether it was working right. That's their problem. It's not my problem. This siloing of roles is the past. Today, you want the practitioner, a data practitioner, to be responsible for their own data, have the tools to be able to do that. They should not have to deal with a different set of tools for their data engineering, a different set of tools for building their models, a different set of tools for deploying them and monitoring them and maintaining models, just like in any other field. So at vue.ai, one of the jobs that we have tried to do is build a platform where all of these skill sets come to one place, right? So the modern tools baked into a system that allows all of these roles to be catered from, for them to collaborate, even if you have different people of different skill sets. These tools allow your data practitioners to be a lot more effective and not have to wait on silos of skill sets to all cooperate to get things done. Humans are always the bottleneck in the system, right? So we reduce the burden to fewer and fewer humans, and then you can blame only one person.
Or one tool. Yeah. So, 2 questions, Shrikanth. So, one is between the trading desk, the quant, the trader, the quant guy who is like working with the trader, and like say our side, like which is data scientists building the models. How does doing something like this change the way they work on a daily basis?
Yeah. I think it sort of follows from what Anand mentioned as well, right? So I mean, in a traditional system, you'd have data flowing through into a database, data engineering platform, but then data scientists taking the data out, looking at historical data, building algorithms, which can deploy it back into another platform, and then it being delivered through an application or a report to the traders who actually consume it, or the salespeople, or the whoever is consuming it, right? And the feedback loop takes its own sweet time to come back and change and so on, right? But now with a platform where what we are working on right now is it's a single interface where I can bring in data, collaboratively look at data, explore the data through either visual or code, along with a business user. Look at so feature engineering is not done separately in Python or some other coding language by a data scientist who then reports back after a week with charts and say this is what I did, and then goes back into the cave for few more iterations. You can actually in real time collaborate and get feedback, change feature engineering and so on, so that you build a model, and then the same model artifact can be very easily deployed by a business analyst, because who doesn't even understand data science, but the model artifact is available, you deploy it for reporting and analysis, and the feedback loop can come back the same day, right? So this allows for much more rapid iteration. That's one. The second, very interestingly, like Anand said, is as you work on the same platform, people start picking skills from other people they're working with, right? So a data engineer starts learning a little bit of ML ops, data science, data scientists start doing data engineering work and so on. So it's not really they become specialists, but at least they learn enough about the end-to-end pipeline to recognize and say, okay, there is an end-to-end value chain, and it's not my work is siloed, so they can collaborate on it. So there's a change in the team working style as well. Okay, and so paradoxically, in a sense, right, the team is becoming more generalized and working similarly, but the models and the agents are becoming very specialized and so on. So we are actually making humans more generalized and work end to end, right? While the systems actually work more specialized, which is essentially what vibe coding is also about, in a sense.
So, I have one spicy question for both of you, which is, I mean, since when we started Moative, like we've been talking about simulation in various contexts, and like with so much behavioral things that are affecting like pricing and so on. What is, I mean, can we even get to simulating the market? That's one question. And what is your perspective of simulating? So a market is a brain. So from a neuroscientist perspective, what does that look like? So either of you can go first.
I'll maybe take just a few seconds.
We have 10 more minutes for questions. Yeah.
So what he's picked up is somewhere here at the bottom. Okay. So essentially, one of the things that we are trying to do right now with the utility company is, I mean, while we are building specialized models for different, say, weather patterns in trading, other traders, other generation companies, how consumers are behaving, how transmissions behaving, we're learning more and more about the entire system. I mean, not just the actors, but also the physical assets, right? The transmission, transformers, all of those as well. So in a way, and we are getting data from all of those, which are consuming those as well as part of our models. So, but we are doing this piecemeal. Now, what we're trying to experiment with is there a way to actually build sort of a digital twin of the entire network? Right, so I'll know where the assets are, where the generators are. I also know how much power each generator is producing every day. I know that, right? What I don't know is, say, how each of this interact with the grid. What are the actual physical realities in place, and so on. So some of those are black boxes there, which we can then try to actually model and simulate as well. So we're trying. It is a fairly large endeavor, but it's something that I think if we do, it'll be a boon, not just for the utility that we are working with, but the data products that is coming out of it can be consumed by any player in the energy industry, whether whether it's a generator or it's a household with a PV rooftop who wants to know how much money they can make and so on, right? So that's where we're trying to use, a digital twin paradigm to actually model the grid and see if we can simulate.
So essentially, we are thinking of use cases for simulation. And the first situation where it seems like we can apply this to is like for a utility company. But the things that we are thinking about, simulation in general, but applied in the context of energy, can be applied across the energy value chain. You can simulate demand, simulate supply, simulate congestion, all of that, right? Over to you.
All right. So since he said, give me the neuroscience perspective, I'll go a little off into professorial mode.
Your feelings.
Opinion, not fact. Your brain has a digital twin of the world outside it. You are simulating the world right now. You are not processing this information. You're not in the matrix, don't worry. You simply don't have enough information flowing into your brain. You have 1 million ganglion cells in your eye. That means you have only 1 MB resolution per eye. How are you processing all of this? You're not. The information flowing into you from all your senses is very tiny, despite all of this firepower. Most of the firepower is actually simulating the world. You are generating a reality in your brain and projecting that outwards. So this neuroscientists do know that there's 10x feedback then in input coming in a feed forward manner. So that means at any instant in time, you are comparing the sliver, the sparse information coming in from the world with your simulation of what the world should be at that instant. So if they match up, you don't have to do anything. That means your brain has already predicted, this is reality. Yes, reality matches my prediction of reality. I'll just do what I'm supposed to do in such a situation. Great. When it doesn't match, when there's an anomaly, that's when your brain kicks into gear. So when the input signal is in odds with your model of the world, your brain kicks into gear and recruits the specialists, microcircuits in your brain to act on that kind of anomaly. So you are simulating the world, and anything that you don't expect is the only thing triggering action in your brain. Okay, I've taken it to an extreme, but you get the picture. Now, if you build systems like this, then you can have an extremely responsive brain that's not always active, trying to parse every piece of information. It is simply making a projection saying, yeah, this is what I'm expecting out of the grid, the 300 days. Something's wrong, act on it. You can build and make very responsive and reactive systems that have the same kind of firepower and flexibility that we do.
Yeah, the simulation that he's talking about, that like Shrikanth talked about in energy case, can be easily translated to anywhere there is a real world modeling that is required. Supply chain disruptions, of course you can simulate those, right? So many different variables, but you can simulate those. So the conversations that we have are about like, hey, where all can we apply simulation? One is energy and one is and like maybe like the supply chain and so on, right? We are kind of like close to time, so 5 minutes, 7 minutes open for questions.
So just from our perspective, what is the political impact with all this Trump and all that stuff coming up? Do you see an impact on your business? Does that impact it? Because energy is typically a political subject, right? Second, is there a variation there where you see this being applied in India, or it's just something which you think it's very difficult to do it because of all the data requirements and all that stuff?
Right. So the impact of not just Trump, the impact of policies, right? Impact of policies always felt. For example, in the utility scale like solar and wind development, the tax credits are going to be pulled back. So as an outsider, you would think that this is not the right time to go and do AI solutions for that industry. But it's very counterintuitive. It's not. It's the best time to go there because the tax subsidies and so on will be tapering off from 2027. So there's a rush to finish these projects. Whatever money has already gone on stream is trying to spend. I mean, they're trying to spend it as efficiently as possible before the tax credit, cutoff time comes. So there's a lot of automation opportunities because they want to do it fast. right? But will this also mean that like some money is cut for some lab which is working on like new age turbine for hydroelectric power project? Yes, innovation is kind of getting pushed back. So there are good and bad like, but in some pockets it's good, in some pockets it's not good, right? Will it apply for India? Will it apply for any other market? Like all of these like power generators have high fidelity data. Market data is like public, so it can apply as well here. In Texas kind of market where it's deregulated, the price of power is market determined, so there is profit and so there is motivation to do it. In India, most of the electricity boards are bankrupt, so they may not have like the incentive to invest in forward-looking technologies. That's the difference.
So in India, because of the changes in regulation with IEX coming in, with say solar and wind especially, and also other distributed generation companies which are feeding to the grid, there is some change that's happening. We think that we've worked with a few some of players in renewable energy here in India. While there is focus more on the predicting the generation part, the market volatility fluctuation, those are still not a big concern, right? So there are pieces of work where we can work with, but we see that maybe 4 or 5 years later, this would probably be applicable here as well. There is change happening, but it's, as in like everything in India, it's slow and and you can't use AI to predict. Yeah. with simulation you'll land and you won't know.
Yeah, hi. I'm Arvind, and I work for a startup called SkyServe. We are in I just wanted to ask a question because of some overlap, distant overlap that I see. So we've built a. Okay. That's fine. So we've built an MLOps tool, which MLOps tool of framework, which helps folks to deploy ML models on board the satellite edge. So, like some of the things that it's a different way of operating and dealing with things, but we tend to think about like model security, those concerns. I see from what you have described, you've built the entire chain of probably you have a custom on-prem way of architecting and working. So I'm just curious about like not the domain apart. What are the other challenges or other things that if you could shed some light, it would be.
I'm not entirely clear about which challenge you're talking about, but yes, you are right that the nature of such a deployment does involve a lot of proprietary data. And this is not about the energy industry at all. Right. In most industries that have proprietary data, that data is IP. The models themselves are commodities. There are a ton of models out there. A lot of different models will work. In an MLOps system, its job is to pick the right model with the right hyperparameters to work for the data at hand. So it all comes down to data security, the model being in there, and making sure that nobody corrupts the data, injecting information that might make the models misbehave. So the challenges that I'm projecting a little further that you will encounter is that once you do have a established pipeline of information feeding into models and a mature MLOps practice, I think poisoning the data is something that people should be thinking about, because then you can make the model behave in a way that you can exploit, and that becomes a national security implication, not just the profit and profit situation. However, it's going to be exponentially harder to do that, especially when you have a distributed system where no single signal rules. If you follow standard practices and build your models in a place where you are accounting for standard errors that are happening across this place and building models that are corroborating each other's signals as opposed to making one model make a single decision, then you can potentially also ameliorate the potential risks that come from that. I don't know whether that was the direction you headed towards, but that is a potential challenge that companies will have to deal with. But as long as they are proprietary and staying in-house or on-prem and so on and so forth, then it's more about protecting the ecosystem from infusion of bad players or bad signals, not so much the systems in place themselves.
Okay.
Did that make sense? Yeah.
I think we run out of time.
See, we've been reviewing companies in sustainability reward space, right? So one of the operational challenges that we notice is having a standard calculation of the benefits to the customer from a consumer standpoint, right? So morning I was reviewing a company where they track transactions and then they connect it to the POS system and say, okay, you know what, how do you be green assured, right? Versus, okay, do you want to buy a product, brand A versus brand B? Now, so I think the whole conversation was, okay, Visa can give you data, MasterCard can give you data. But then one challenge that I notice is I don't think all categories from a consumer standpoint is being covered in the right, not the right manner, in the same level, right? Certain sectors have evolved models where you can do a dynamic calculation and say, okay, don't buy product A, buy product B. Whereas you don't have similar calculations being done at scale with millions of data points being processed. When you don't do that, from a consumer standpoint, I don't necessarily see a value in that the binary decision, do I go for this versus this? I'm not getting rewarded real time. And until that happens, I don't think you're going to see a habit shift, right? So are you seeing the ecosystem evolve, leaving aside the competitive aspects? Are you seeing the industry across categories evolving so that from a consumer standpoint, I get to see the value of a decision that I'm making, right? So I know whether it's just you were talking about energy, but I'm also talking about spends because I think every transaction leads to buying a product which has different energy consumption happening. Is this something which you have seen as a problem being highlighted by the industry? Or is it too early to even discuss about, as a customer, when I purchase 10 products today, I get to know what's happening across different categories?
Yeah, I'll speak for both of us because we both have e-commerce lineage. They work with a bunch of e-commerce companies and we built an e-commerce intelligence company, right? Nobody wants to solve this problem because the supply chain traceability is siloed in each company and they know where they're buying from and what the environmental impact of the purchases they have. Right? And all the retailers would want to share this data for you to build a model which is actually useful. There's no incentive to do that.
There's no incentive, but interestingly, I see brands waking up to this, saying that in comparison to a traditional advertising, people see that a sustainability reward-based communication is going to build a more committed, loyal customer base. Right?
You are correct, but are they lying?
Yeah,
or are they
exactly.
communicating the truth? There's a lot of greenwashing happening. And so you're correct that there is incentive to portray a company as green. Pointing out there's no incentive to actually be green in such situations.
Maybe also a slightly different viewpoint from this. One is about whether you're lying or greenwashing and so on. But the other point also is, who are they targeting this message at? Right. So if you look at the,
just wait. So when you say who, from a brand standpoint,
standpoint, they're targeting this message at consumers.
Yeah.
Right. Now we worked with, say, for example, with a few brands earlier in a previous startup, where we were looking at, say, vegan or health conscious and so on. How do you? So all of these are niche audiences, especially even in India. If you're looking at e-commerce brands, D2C brands, everybody knows, right? It's just a small niche audience, and it's the same audience that every D2C brand, whichever category you're targeting at. And within those also are the people who are actually conscious about health and values and environment and so on. So any differentiation there will help you capture a niche.
Yeah, so
right.
You are correct, and it is probably right that people should be conscious of this. But when it comes to consumer choices, they are not that.
So you're saying it's not a capability issue, it's more of a willingness issue.
Willingness from multiple places, yeah. So even the great consumer.
Yeah. So
but if there is willingness, data they will see merit in exposing data, isn't it?
But it's interesting.
Thank you. Thanks a lot.
Thank you so much, Ashwin, Anand, and Shrikanth for joining us for this session. If I could just call Girish and Rohit, who are Opeka founders, to come up to give out the tokens of appreciation to Anand and Shrikanth. Thank you so much for joining us. We will take a quick tea break. Okay, sorry, just one last picture. Thank you, folks. We'll take a quick tea and coffee break, which is available on the veranda next door. We'll be back here at 4:05 for AI in banking and regulation. We'll have Sharda Balaji moderating that session. It will be a cracker of a session, so looking forward to having you guys back here in 15 minutes.